Yo guys, just answer me this question in the comments. How the hell are you? I hope everyone comments this, because today is the start of something fun. Now, I want to show you something. This that you're looking at is a completely unique Pokemon that was generated by an AI autoencoder that I've trained in only a few minutes. Alright, you caught me. The autoencoder doesn't generate results this high of quality. I actually paid a human Pokemon autoencoder to interpret what this Pokemon might look like based on what an AI has generated. If you want to see what the AI generation actually looks like, and what this image was actually inspired by, well, here are the actual results. Not bad, but also not so good. But don't worry, I have some tricks up my sleeve to improve the results beyond this. But before we get into that, let's take a step back and talk about how we got here in the first place. I recently have been playing around a lot with AI autoencoders, and I absolutely love these things. They are my new favorite way to generate stuff using AI. And yes, I still haven't got around to playing with GANs yet. I'm very aware of all the hype they're generating, so you can discard your comment, you GAN enthusiasts. But if you don't know what an autoencoder is, well then, the pleasure is all mine to introduce you. In short, you can think of an autoencoder as two neural networks with two different jobs that work together to solve a problem. So you have some data set, and the job of the first neural network will be to take that data set and compress it, aka learn the most important features about this data set. And so the job of the second neural network is to figure out how to represent what was learned from that data set straight into whatever format you want that data to be represented. In fact, this is the underlying technology that was behind deepfakes in the early days. Though, I'm not sure if they're still using this or not. They might have moved on to GANs these days, I don't know. So let's now say we have a data set of my face. Our autoencoder would abstractly figure out the answer to what pixel patterns makes up my face. And once we're happy with its ability to reconstruct my face, we can then feed the autoencoder things that aren't actually my face. And our autoencoder will then attempt to take this never before seen image, generate a low dimensional representation of it based on what it's learned on how to do that, then pass it off to the second half of the autoencoder that takes this reconstruction and goes,
I have no idea if this low dimensional representation is Jabrils' face or not. Don't really care, to be honest. But based on what I know about Jabrils' face, this is what I think the original image would look like if it were Jabrils' face.
Which again was inspired by the input image that it was fed. And I don't know about you, but this seems like a fun toy neural network to play with, and I would love to have the power for something like this. Anywho, let's get into some actual experimenting. It all started when I downloaded just a vanilla autoencoder script from the web that originally used the Imnis dataset. I just swapped out Imnis for a few Dragon Ball images and just trained to see how well it'd do. And it worked exactly like one would expect. It was able to take some Dragon Ball images and recreate them good enough. And so with that test out of the way, the first thing that came to mind was to work on something I was calling Human to Dragon Ball Z, in which you would be able to input an image of yourself, then it will output you, still, but as a Dragon Ball Z interpretation. But I had one major problem. Collecting a sizable data set for Dragon Ball anything is not an easy task. I briefly thought about creating something based on Dragon Ball Z episodes, because I could just take frames from the show and use that as input data, but ultimately, there was just way too much data prep and cleanup for a questionable payoff. Maybe I'll come back to this some other time in the future. But in the meantime, do you know what popular Japanese franchise does have a bunch of samples that we can use as input data for an interesting AI project? That's right, you guessed it, Pokemon. Pokemon has released so many games over the years, and the best part is, up until recently, they were all in 2D, which will undoubtedly make our lives so much easier. So I went to download some Pokemon data and found myself with one master image with a bunch of Pokemon on it, along with facial variations for each Pokemon. But this was not just any bunch of Pokemon. Oh no. These were all mugshots of Pokemon, which automatically counts as a level of data cleanup as they are all in a similar format. absolutely beautiful. But of course, this wasn't a dataset yet. It wasn't broken up into individual samples, and was in a form what's referred to in the gaming world as a sprite sheet. So I wrote a quick script that would break the sprite sheets into single images, and after the script was finished, I had 1380 images of Pokemon samples on my hands. Nice. A lot less than I think we'll need for this, but orders more than the size we were using for our Human to Dragon Ball Z project. So this should at least let us know if we're heading in the right direction or not. Now, let's get started with the fun stuff, and that's coding up some neural network architectures and do some machine learning training. First thing I did was just modify the script I was using for the Human to Dragon Ball Z project to work with my new Pokemon dataset. It took only a couple minutes tops, and then I began to train a new Pokemon autoencoder. I ended up tweaking the architecture of the neural network to try and achieve a better converged model, but no later than an hour or so of experimenting, I had a trained model that was able to convincingly recreate many of the original input data from a low-dimensional representation. Not all of them were smash hit successes, but most of them did pretty well at first glance. And so now I had this AI autoencoder that took in an image as input and spit out a Pokemon representation. Note that I didn't say takes in a Pokemon image as input, because honestly it has no idea what image that we are inputting, and so there was only one correct thing to experiment with next. Here are my best attempts at drawing Pokemon. What will our AI autoencoder do with them? Let us find out, shall we? Okay, terrible results. In fact, with two different training techniques, we get two different results. Neither of them fruitful though. But this one makes sense at least. All the colors from the representation does at least appear in this Pokemon Gyarados. And I guess here you can see some sort of feature understanding, like this kind of looks like a Pikachu with red eyes. I can kind of see it. And this does look like some sort of blue Pokemon with what looks to me as brown eyes. Okay, it's not completely terrible, just maybe incomplete. Okay, well, what if instead I feeded a few images of people? Yikes. Yo, this one interprets me as a Tangela. Is it because of my dangling dreads? It can't be. I don't know, but that's kind of funny. Okay. Sure, this is a little bit interesting, but the truth is, there's nothing useful or fun about what we've built so far. Maybe it needs more data for training. Maybe we need to input better imitation images that mimic this 45-degree mugshot format. Maybe we need to reduce the color complexity of our inputs. I don't know, but we can't just give up here, because doing so will make this a failure, and as we all know, failure is just success that needs more time. And so I went back to the drawing board to think about where to take this project next. And that's when all of a sudden out of nowhere, I was graced from the heavens above with amazing inspiration for this project.